So basically, we update from the source of named or namedb, and then it's to the destination of the F5 DNS listener on its loopback : 1 port 5353, and that's not a listener like a 5353. You don't have to allow that specific port. It's actually an internal process. So same thing as before, normal A record request comes in to the F5 DNS servers, and then it will respond using DNS Express. Okay, now let's take a look at a live example of on box bind. So we'll go to the GUI first, and we'll follow this same process we did excuse me, earlier with DNS, defining the name server, and I created one for big IP 127.0.0.1 port 53. So pretty basic here. Just give it a name and the IP address, hit finish. Okay. Next thing we're going to do is define the zone that we want to use for the on-box bind. So you're really not stuck to using on-box bind versus off-box bind, because you can use different zones for different on-box bind versus off-box bind. So in this case, we're using domain.com is going to be our on-box bind presence. So what I did is created a zone called domain.com, and the server is that name server we just created. I specified the allow notify from for the loopback address, and then I added the big IP name server again as a zone transfer client. Alright, so next thing we do is we have to update those option values in the bind database. So again, to manage those bind files, you can do that in Zone Runner. So if you go to Zone Runner, then record, resource record list, and then you go to zone list, and you can go to the domain.com, and so we have the I've added the entries for the localhost, allow update, allow transfer localhost, and the also notify statement. So this domain.com will actually create itself when you create a wide IP. So before that, I've created a wide IP just called dnsexpress.domain.com, and since it has the domain.com reference in here, it actually had to create an entry for that in Zone Runner. It actually create the start of authority record for it and the A record it chooses, and that's how it manages those files. The wildcard.domain.com actually showed up differently. I actually thought I would have a Zone Runner. I'll show you the Zone Runner domain.com already, but it gave it a wip.domain.com. So nonetheless, when you create a wide IP, and it'll take that domain and use it to create and pre-populate a new zone if you don't have one. Okay, so that domain.com is referenced here, and then I have updated those specific options. So let's go back to the client, and we'll do a dig to the GTM listener for that new A record. And now, since it's part of domain.com is part of our local bind on-box bind solution, it's going to take what's inside of bind and it's already transferred it to DNS Express. So we do a dig for that IP, and you can see the query time is much faster when using DNS Express. Now it's 4 milliseconds. Of course, it starts dropping when you request it again. But okay, so let's again take a look at what the DNS CLI itself shows us. So let's first look at the DNSX dump. Do a pipe for less, and we're just going to find that DNSExpress.com entry is definitely in the DNS Express database. Okay. Is that same TMSH show LDNS DNS. We can tab out the zone, and we were using domain.com for our on-box bind solution. Okay, we'll push enter, and we've done some queries since the start. As you can see, the 18 queries and responses match a successful zone transfer requests and the proper resource records we have. So when we created that wide IP, which was dnsexpress.domain.com, it actually pre-populated Zone Runner for us, which is super nice, and included the A record, the NS record, and the start of authority record. Okay, so let's take a look at the second big IP DNS feature that we have on the list, Zone Runner. So Zone Runner is really a DNS GUI management system, and the biggest thing about it is it allows you to verify the syntax before actually putting it in place and causing an issue to production, like from a traditional bind server. Some of the features include importing and transferring the zone files from different name servers, and you can do this dynamically or just copying the file and loading it on the big IP DNS. One of the biggest is managing the zone record resource records. So it's nice and neat, and unlike different Unix systems that support bind, there's database files, and really the contents are kind of spread out and they're not as clean, and really it allows you to create a which is the second one. The third one actually is the DNS view. So external and internal DNS views can be created. You can create a specific view, maybe for a DMZ type resource that you want to allow certain requests to transfer. The fourth option there is manage the local name server and the associated configuration file, like name.conf. So you can actually use the F5DNS to manage the platform of a bind server. So you can do all the configuration in Zone Runner, and then through a zone transfer you can update other DNS servers. The fifth option there is transfer zone files to a name server, and 6 is import only primary zone files from a name server. So really it allows you to act as a primary or a hint zone, different like secondary zone, things like that. You can import specific pieces of a zone file if you choose. Okay, so I wanted to show you an Ask F5 article about Zone Runner. So you can go to support.f5.com and go to the Knowledge Center, and you'll see services. You can click LTM, then in the DNS services for implementations, there's Zone Runner. You can also go to Google and type in Big IP DNS Zone Runner V13, and it'll be one of the top links for Google or other search providers. Okay, so let's scroll down to the bottom where the zone types are going to be and the resource record types. Now these are all zones and resource record that Zone Runner supports. So let's go through these zone files real quick, just so we have a good understanding of what you can create. So the primary zone is what we've seen basically the whole time. It's the start of authority for the name server records for that specific zone, and it's got to have at least one NS record associated with the SOA record. Okay, the secondary zone is much like a delegation server. So remember in that earlier example we had a external DNS provider, and where we're delegating to a secondary name server, which in that previous case was the F5 DNS, the zone file information is going to be the same because it's copied from the start of authority name server or the primary zone. And it's done, that information is done via a refresh interval. So the lower the refresh interval, the more often it will check and pull the data from the primary zone. The stub zone is really not used or not recommended to be used by F5. It's really part of a native bind implementation. That's just part of bind in general. But if you do use it, it contains only the NS records for that zone. A forward zone is what we'll talk about with a split DNS configuration. But what it can do essentially is also choose to forward specific DNS queries to a specific name server on a per zone basis. So we'll get into more of that in a little bit. The hint zone is really, A through M is the hint servers out on the internet. You can specify a subset of those A through M servers if you'd like for a specific zone. Not really common to use, but it is available. Okay, so now let's jump into the resource record types that you can create via Zone Runner. So the start of authority record is automatically created when you create a wide IP, but this is essentially what every zone has for the primary zone. So the SOA record indicates who's authoritative for that zone, and in this case the F5 is going to be the start of authority record if it has that zone, if it's authoritative for that zone. An A record is what we've seen too, is it's very common. It's used to resolve an IP address to a host name. So that's for IPv4. The quad A resource record is for IPv6. So it's used to take IPv6 and translate that to give you a host name. The canonical name or CNAME is an alias of an A record. So we've seen many examples of that. The DNAME is essentially a reverse lookup of, the substitute of the suffix of one domain. So I have a specific example. It's basically used to take maybe example.com to example.net and then rewrite that to the highest part of the domain, which is like host.example.com. If it translates that to example.net, it's going to be host.example.net. I have a specific example from an RFC 6672. So if the query name is a.example.com and the owner DNAME associated with that is example.com, the target is going to be example.net and the result would be a.example.net. So it's very high level case. There's many observations for DNAME records. It could be used for IPv4. The main purpose was for IPv6 to try to help with some of the numbering and allocation for names to IPs, but it can be used for IPv4. Okay, so a host information or hinfo record is used to contain information about the hardware or operating system of the DNS server. And let's take a look at that via the command line. So we'll configure hinfo record type. So we go to Zone Runner Resource Record List. We're under domain.com, and we'll choose hinfo. Okay, we'll give a TTL, let's say just 10. We'll copy the host of the F5 system, and then we could specify a hardware type if we wanted to. So we'll do F5 big IP DNS VE and the OS 12.1.2. Okay. Yeah, this is kind of tricky because we're including a domain name inside a domain, um, so we can remove that so it's a little easier to see rather than a really long FQDN. But we'll click finished here. Okay, so now we have that as an hinfo record. So if we go to our client system, and we'll do a dig to the GTM listener for the the resource record type hinfo to, in this case, it'd be domain.com. And it just took a little bit of time, but so you see in the answer section is the query name. The TTL in this case was 10, but the resource record information that it gave, the host information, was the hardware and operating system. So this is a quick example. Also, let's configure a TXT record, since they're very identical or closely identical to what an hinfo record is. Okay, so let's say we want to give a TXT record for app.domain.com. So we specify app, and then it automatically appends to domain.com, so you don't need to include the whole FQDN. It will do it. If you do like the whole name, it will append it twice, which you don't want. So let's just do a TTL of 10, and the text that we want to say is only used for QA. So if there were specific server teams that were maybe doing DNS resolving, and they were doing it for all resource record types, I'll show you that in a second, then they would be able to see some comments, which may be useful, persistent information if you're doing a lot of changes for QA, or maybe this is a cloud environment, and it may be a nice option to use for identifying systems. Maybe not for production, but possibly for a QA environment. Okay, so we'll click finished here, and the appdomain.com is created, the TXT record. So it might take a little bit of time, but let's do TXT record, and we're going to do app.domain.com. Okay, so the answer section, app.domain.com, somebody's telling us that, hey, you should only use this host for QA testing or something. So if somebody was wanting to get information about app.domain.com, maybe there's a migration coming up that you need to move all these applications to a different load balancer or something like that. Well, if you've had TXT records associated with a specific URLs, you can do +all to get all the resource record types. And it actually didn't show up. So maybe if you need to actually get specific TXT records, you can find it. I don't know why it should include all the resource record types for that specific FQDN. But nonetheless, if you know it's there, it's a good thing to check. Okay, so let's keep going down the list. We ended with the hinfo when we talked about the TXT record type. The mail exchange record is for mail systems for given domain and a priority. We talked about this in a couple of videos back. The NAPTR is a name authority pointer, and it's a standardization for uniform resource names, or what they would be before they become URIs, to put it simply. It's basically used to suggest to clients the protocols available they have to map to a resource. So it's allowing the application to choose a mapping of a specific protocol. Well, let's take a look at an example RFC. So in this example, we have the gatech.edu, and what it might look like is we have 3 NAPTR records with the same order. So really the client or application can choose to use any one of these records. Sorry, the preference is the same, 50. S means this is the last NAPTR records the client should expect to see. So we see 3 different services, and what the regex is simply doing is it's just replacing the content. So we have the service, we have the specific services here, and the regex, which is performed above using the CID of the URN, but we have these 3 mappings that we can choose from because the preference is the same. Alright, so let's say we assume the application or client chooses the Z3950 protocol. Okay, that lookup is done, and it might return 3 SRV records, which SRV records are service records that tie a name to a specific protocol. So you'll see this to help maybe like Exchange users the ability to find an Exchange server. Like Microsoft environments use this a lot to try to point to a specific URL the client may not know about and the port that it needs to tie to. So it returns 3 SRV records, and then the client has 3 targets to choose from for that specific protocol. Okay, so let's talk about the last 2 resource record types that ZoneRunner supports. We could do the common name server record. So this really is associated with SOA record of the zone, and what a name server record is the true data. So anything that can be cached from a DNS, like a local DNS server, well, that's not really the name server record. It's not the authoritative or primary or secondary authoritative name server. The PTR record is simply the opposite of a record and a quad A record. So instead of resolving an IP address to a name, it resolves a host name to an IP address. And you'll see this a lot in Active Directory environments. It's not often that you would need to have it, but it is really helpful for troubleshooting. Okay, so let's talk about the third big IP DNS feature, DNS 6.4. Okay, so DNS 6.4 has 3 modes that you can use to mitigate IPv4 address exhaustion, which basically in the United States maybe not as a problem right now, but for maybe other places where they need they have only IPv6 addresses available at the moment, they need to be able to support the translation between IPv6 and a mixed environment. Let's say they have IPv4 and IPv6 in their environment. This is a nice way to ease the transition if you're not all at IPv6 internally. So this is really all of these examples for the response from the client to the DNS server, and then the F5 sends it back. So no bind is being used or DNS Express in this instance. So we'll need to have the big IP DNS license and the CG NAT, carrier grade NAT, to support big IP DNS 6.4. Okay, so let's start with immediate mapping. So the client sends the IPv6 query to the F5 DNS, and the DNS will send both the IPv6 query and the IPv4 query to the DNS server. Whichever response it gets back first, that's the one it sends to the client. So if it gets the IPv4 A response back first, it will take that and append a 96-bit prefix. So it's a really nice way to identify the um, the specific IP address of the IPv4 and then apply that prefix, making it IPv6 compliant basically. Alright, so the second option is the secondary mapping, and the difference here is that the big IP sends the IPv6 query. If no response, then it will send a query. So notice it'll send the quad A query first and then wait and then send a query. So it really wants to be able to check if there's a proper IPv6 address that it can send to the client. And the third option is, okay, you only have IPv4 only in your environment. So same process, IPv6 query, it forwards that back to the DNS server as an A query. So changes that, gets the A response back to the F5, and the F5 will append that 96-bit prefix. So in this video, we talked about some big IP DNS features, specifically DNS Express, an off-box bind example, and an on-box bind example. And then we ran through some live demos of that. We also talked about Zone Runner and created a few records via Zone Runner and did some dig lookups, and then talked about DNS 6.4. So up next, we'll talk about the rest of the DNS features on our list. So I will see you in the next one.